equation of tangent in different forms, let us solve a few questions for better understanding. So let us say we have a question. So the question says a circle is given to us. So let's say the equation of circle is x square plus y square plus 4x minus 4y plus 4 equal to 0. Tangents are drawn to the circle such that they cut equal intercepts on the x and y axis, and let us take the positive x and y axis. So tangents are drawn to this circle such that it cuts equal intercept on both the axes. On the positive side, so we have to find the equation of the tangent. So this is the situation and we are supposed to find the equation of the tangent. So one approach could be from the condition of tangency, that the distance of the line from the center should be equal to the radius. If we put that condition, we will get the equation of the tangent. Now here there is another condition that is given to us, that the length of intercepts on both the axes are equal, which means if we consider the equation of line in the intercept form, remember it is of the form x by a plus y by b equal to 1, where a is the x intercept and y is the b intercept. Now here, since it is given that a is equal to b, we can write our equation as x by a plus y by b, y by a equal to 1, which gives us x plus y minus a equal to 0. So this is a straight line and the value of a is what we have to find. So for this circle, clearly the center is minus 2 comma 2, and hence if we apply the condition of tangency, what we have is minus 2 plus 2 minus a divided by under root 1 square plus 1 square modulus. Now this is the perpendicular distance from the center on this line. The radius of the circle, let me just calculate here, is equal to 2 square plus 2 square minus 4. So 4 and 4 cancels. What we have is under root of 4, under root of 2 square, and that is 2. So this should be equal to 2. Now if we simplify this, clearly this cancels out and we can straight away write a is equal to plus minus 2 root 2. So if you try to put the values, the value of a in the line, what we have is x. So therefore the equation of tangents we have got our x plus y minus and plus 2 root 2. If we rearrange this, we have x plus y equal 2 root 2 with a plus and minus sign. Which means if you try to visualize this with the help of a diagram, so we will have a circle and there would be coordinate axis. So this is not drawn to scale. You can draw this accordingly because the x coordinate is negative, so this should be on the left hand side. But what I'm only concerned with is the tangent. So let us say if this is the tangent, then in all cases the y-intercept is going to be positive. So if we take this equation, here there is a plus sign and a minus sign. If we take minus sign, it means the y-intercept is negative, which is not the case because here the tangent is cutting the x and y axis in the positive direction. So we have to ignore the negative sign, and according to the question, therefore the required equation is x plus y equal to root 2. So this was one way of solving a question using the condition of tangency. Now this condition of tangency is very important. This can be used at all places wherever the case of a tangent is given to us. Now let us try to approach this question by another method. So the other way could be, we are given this equation. Can we write this equation in another format? Definitely we can. So let us try to do that. So we write this equation as x plus 2 whole square. So here we are bringing together x square and 4x, and there is an additional plus 4 term which we have taken here. Now we again do the same thing with y. So y minus 2 whole square. Now there is an additional 4 coming there. So we take 4 on the right hand side, which will cancel out, and hence this equation represents the same circle. Now we remember, for a circle x minus h whole square plus y minus k whole square equal to a square, if the slope of the tangent is m, the equation of a tangent is given by y minus k equal m times x minus h plus and minus a times under root of 1 plus m square. Now here let us imagine the same case. Now since the tangent is cutting equal distance on both the positive x and y axis, so what we can have is, we can easily say that this angle is going to be 135 degree, which means the slope of the tangent we can easily find out, and that will be tan of 135 degree is equal to minus 1, which means we have calculated the slope. And if we apply this formula, we can write the equation of tangent as y minus 2 is equal to m is minus 1 times x plus 2 plus and minus a into 1 plus m square. Now a here is the radius, which is equal to 2 in this case. So let us simplify this. So what we have is y minus 2 equal minus x minus 2 plus and minus twice under root 1 plus m square. M square is minus 1 whole square, which is 1. So from here we can cancel out minus 2 from both sides, and we can bring x on the left. So we have x plus y is equal to plus and minus 2 root 2. Now again, using the same logic, since the intercept y-intercept is positive, we have to ignore the negative sign, and therefore the required equation of tangent is x plus y equal to root 2, which was this case when we solved this using another technique. So this you can say is our method 1, and this is the method 2, and this is only to give you an idea as to how do you approach a particular question. There would be cases where method 2 would be more useful than method 1, and there would be cases where method 1 is more useful than method 2. So this is the right time where you got to practice a lot of questions so that you can understand in which situation which method you have to take ahead with. You have to proceed a question with which method, and then it will be easier for you to get the solution and easy marks. Let us now try to solve another question related to tangents. So here let us say the question says we have a circle x minus 3 whole square plus y minus 2 whole square equal to 4, and we have to find the tangent which is passing through the origin. So let me just write the question first. So the question says tangents are drawn to the circle x minus 3 whole square plus y minus 2 whole square equal to 4, such that origin lies on them. Find the equation of the tangents. So let us try to solve this question. Now we have a circle and tangents are drawn basically from the origin. From the origin there can be, let us see first of all how many tangents can be there. So if we try to plot this point, plot this circle on a xy plane, so this is our x axis and this is our y axis. So the center of the circle is at the point 3, 2, which means it is here, and the radius is 2, which means this is 2, and so the circle would be passing through these 4 points. Let me draw these points, and the circle is passing, so our circle would be something like this. And since origin lies outside the circle, so clearly we have an idea that if a point lies outside the circle, we can draw 2 tangents. So let us see how we can do this. So any line passing through the origin has an equation y is equal to mx, and plus c becomes 0 because y intercept is 0. Now since this line is supposed to be a tangent, we can write this as mx minus y equal to 0, and we apply the condition of tangency. What we get is 3m minus 2 upon under root of m square plus 1 modulus is equal to 2, because 2 is the radius. Now on squaring both sides, what we have is 9m square plus 4 minus 12m is equal to 4 plus 4m square. 4 and 4 gets cancelled, and what we have is 5m square minus 12 equal to 0, 12m equal to 0. From here we take m common and we are left with 5m minus 12 equal to 0, which means m can either be 0 or m can take the value 12 upon 5. Now, if you see from the diagram itself, we can draw two tangents. One tangent will be something like this, and the x-axis is another tangent which was clearly evident in the first case itself. So, the line which is y equal to 0, that is the x-axis, has a slope m equal to 0, and the other line which has a positive slope is equal to, the slope is equal to 12 by 5. Hence, the two tangents that we have are y is equal to 0 and y is equal to 12 upon 5x. So, this was one question. Now, let us try to solve another. So, in the next question, let us say we are given that there is a circle. So, I would not write the equation of, I would not write the complete statement of the question. I am just going to explain it to you. So, let us say we have a circle given by x square plus y square equal to 5, and at a point 1 comma minus 2, tangent is drawn on this circle, and this tangent is such that it touches another circle x square plus y square minus 8x plus 6y plus 20 equal to 0. The question says we have to find the point of contact of the tangent to this x square plus y square equal to 5 at 1 comma minus 2, where it touches this another circle. So, let me just number these two equations, number 1 and number 2. Now, clearly if a tangent is drawn at 1 comma minus 2 on circle 1, the equation is straight away, if you remember the formula, x(x1) plus y(y1) equal to a square, which is 5. Now, substituting the values, we have x minus 2y is equal to 5, which can be rearranged and written as x is equal to 2y plus 5. So, this is, let us say, our equation number 3. Now, if this line which is given by equation 3 is a tangent to the circle by given by equation number 2, then if we substitute the value of x in this equation, we should get a unique value of y. So, let us try and do that. So, basically what we are trying to do is, we are trying to solve this line and this circle. That will give us the point of contact or the point of intersection if there are more than one. So, let us try to do that. We substitute it there. We have 2y plus 5 whole square plus y square minus 8 times 2y plus 5 plus 6y plus 20 equal to 0. Let us simplify this further. We have 4y square plus 25 plus 20y plus y square minus 16y minus 40 plus 6y plus 20 equal to 0. Let us see what we can cancel out. So, we have y square here and y square here, that makes it 5y square. Now, we have 20y minus 16y, that makes it 4y plus 6y, that makes it 10y. So, now what remains is the constant term. So, minus 40 plus 20 gives us minus 20, and plus 25 gives us plus 5 equal to 0. So clearly this equation reduces to y square plus 2y plus 1 equal to 0. So what we have basically done is taken common 5 and divided by 5 on both sides. Now y square plus 2y plus 1 is y plus 1 whole square, the easiest of the formula that you have studied, a plus b whole square. From here there is only one possibility which says therefore y plus 1 should be 0, and that is y is equal to minus 1. So on solving equation 2 and 3, we have obtained just one value of y, and which means this one value of y would give us one corresponding value of x, which means it will give us just a point. And since the intersection of a circle and a line is just one point, this line is also going to be the tangent. So if we just substitute this value of y equal to minus 1 in equation 3, so from, let me number this equation number 4, we can write from 3 and 4, we get x is equal to minus 2 plus 5, and that is equal to 3, and hence the point of contact is 3 comma minus 1. This is our point of contact.